Good afternoon. Today we are working on our math packet number 1. Our first page is Lyra the cat has led an amazing life. Lyra spent the first 1/4 of her years in a seaside cottage. Then Lyra snuck aboard a ship and became the ship's captain for a little while. When the ship reached shore, Lyra explored Charleston Harbor for 2 years. A trucker found Lyra and took her with him on as many trips across the country. She traveled with the trucker for half her years. Now at the age of 16, Lyra has found a small farm to call home. How long did Lyra live on the ship? So we need to track all that information. So I'm going to say this is Lyra's life. We know Lyra is 16 years old, so all together it's 16 years. So Lyra spent the first 1/4 of her life in a seaside town. If we know her life is 16 years, a 1/4, we're breaking that up into 4s. A 1/4 of 16 is 4 years. So for 4 years she was on the seaside cottage. Then Lyra's aboard the ship for we don't know how long. So I'm going to put a little question mark for on the ship. Then we know she explored Charleston Harbor for 2 years. Well, I guess I didn't really need to break it into 4s. We just know we broke that 16, we divided it by 4. So these ones I don't know exactly how long it is. So we know it was 2 years. Maybe I could spell years, right? My goodness. 2 years she's in the harbor at Charleston. A trucker takes Lyra with him across the country for half of her years. So a half of 16 is 8. So 8 years she's with the trucker. We need to know how long she was on the ship. Once we organize the information, we can figure this out because we know she's been around for 16 years. So we use that 16 years to organize what we know, and we can subtract out what we know, and we're left with how long she's on the ship. When it says answer, that's where you're going to write your answer. When it says why my answer makes sense, you can just draw an arrow to what you were working out. You can write it in words, but you do have to show your work. You have to explain how you got the answer. If you're doing all the math in your head, you have to write it out. What did I do in my head to get that answer? The next page, we have numbers 1 through 7. You get each number 1 time. We've got 7 circles. You're going to put those 7 numbers into those 7 circles. And you're going to make sure that every line, adding them up, equals 12. So some of us put it in and we found 3 ways to make 12, but that 4th way didn't make 12. You got to erase it all and start over. Okay? Your answer is the picture. Why my answer makes sense? They all equal 12. Or you could even put, well, I have 5 plus 3 plus 4 equals 12. I put 7 plus whatever equals 12. You can write out each of those lines to show that it equals 12. Luke?
Because all the lines with connected circles equals 12. All picture, right?
Yeah. All right, 5-card challenge. You've got 5 cards. The ace equals 1. Blackjack, it could be 11, but 5-card challenge, it's 1. Pre Algebra needs to equal 15 points altogether. You can go above and beyond. You can get 16, 17 points because you needed to find a new equation. That's what you got. You could challenge yourself to find geometry's points. Mr. Schultz has told me that the high score for 6th grade is 150 points. So you can try to challenge yourself. As the year goes on, it gets easier and easier because we get more used to working with that order of operations, all the different operations. It doesn't just have to be adding and subtracting. You can do multiplying and dividing, using parentheses. Think about that order of operations. Using exponents when we're learning more about those exponents and how we can use them. Square roots. But you need to make sure you have the certain cards that you need in order to do exponents and square roots. So as we're going through the year, you'll pick up more tricks. So, easy one, 8 plus 1 equals 9. All of our equations need to equal that last card of 9. So this is 1 card, 2 cards, so this equation is worth 2 points. That 9 doesn't count as a point. The solution doesn't ever count as a point. Just which of these cards did we use in our equation, that's how many points you get for that equation. You cannot repeat equations. You can't say, well, 8 plus 1 and 1 plus 8 equals 9. Nah, that's the same thing. You can't repeat just by shifting. Okay, it has to be new equations. All right, next page. Pattern page. Now, I haven't gone through what I scanned because I thought I went and scanned it and it was all fine, and I discovered with the Math 6 video that when I scanned it, 2 pages stuck together, so I was missing some. So if I skip a page, let me know, and I'll put it under the document camera so we'll get it all in. All right, for the pattern blocks, we will always have a pattern page. You need to look at what the directions are for pre-algebra. First step, complete the table. You might be leaving a little early. Hello, this is Kate. Yes, she is on her way. Thank you. Yep, bye. All right, have a great weekend.
Thank you.
And I'll be posting the video on my YouTube channel, Fallon. I'm going to post it on the YouTube channel, so if you need to look, if there's any pages you weren't sure on, you can watch it this weekend or next week. All right, first thing is completing our table. Figure 1, figure 2, figure 3, figure 4. We're given the first 4 figures. How many blocks are in figure 1? How many in figure 2?
3,
Figure 3?
5,
Figure 4?
7.
Now, our job is to find the pattern. It's our first math packet. He gave us an easy pattern. Right? What pattern are we noticing? Adding? Add 2. We're putting down the odd numbers in order. Right? So you're going to complete the table all the way down to figure 10. This bottom one says N with a GEO under it. GEO stands for geometry. You won't have to do that until you get into geometry class in 9th grade. Okay, so don't worry about this. We have an answer. Oh, we have a question. We only have to put something on the answer line if we have a question. It says, how many blocks will be in the 12th figure? Well, our pattern only goes to 10. So you have to figure out how you're going to answer that. And you're going to write on the answer line how many blocks will be in the 12th figure. So you're figuring out down to 10. There's an 11, then there's 12. So figure out what your answer would be and put it on the line. Next page. We'll always have pages like this where we're working with our shapes. We need to answer what is the perimeter and what is the area. How do we find the perimeter of a shape? David?
We add up all the sides.
Add up all the sides. So you have to notice if there are sides that don't have a number next to them, you need to figure out what those numbers would be. You can't just skip them. It's still a side to our figure. So you have to use the information that we know, like from here to here is 10 centimeters. So we're going to take away 3, 3, and 2. And we're going to be left with our unknown spot. So if I have 10 minus 3 minus 3 minus 2, what am I left with? Say it out loud. 2. So we're left with 2 centimeters. I'm going to write a 2 right there. Going on this side, I have 6 centimeters and 3 centimeters. So how far is it from here to here? It's going to be 9, right? That's 6 plus 3. So I need to make sure I have 9 over on this side. So if I have 3 plus 3, what's missing? 3. So I'm going to fill a 3 in right there. Now I can add up all of my sides to find my perimeter. I'm going to put that right there. If I'm just adding sides, my centimeter measurement stays the same, and it's just centimeters. Okay. How do I find the area?
So for something like this, since it's not a square, you would box off some of the sections and then.
So I want to make, oh, it's going to give me all reds. Okay. I want to make those rectangles because I can't find the area of a goofy shape. So I need to put it into shapes that I can find the area. What's the formula for finding the area of a rectangle loop?
Length times width.
Length times width. So I'm going to find the length times the width, that 3 times 3, and I'm going to put the answer here. Then I'm going to find my length times my width. Oh, that means if I do it this way, I don't know what this width is, I'm going to have to figure it out. Okay, so figure out what your width is, or your length is, times it by your width, and here, length times width. Then you've got 3 areas for your 3 different shapes. Or if you broke it into 4, however many shapes you break it into. Add up all of those areas that you found. Once you add up all the areas, you put the answer here. Any questions on that? Okay. Okay, the figure shown is a cube. Answer the questions for your class. All work must be shown. Well, on this page, everybody has to draw a net. So it says draw the net and label each side. Then we're going to find the surface area. So our first step is to draw a net. Who can tell me what a net is?
It's like kind of like a cross, so it's like if you fold it down.
Yes, when you fold it down. That cube is 3-dimensional. It's like a Kleenex box. All right? So I've got my Kleenex box here like this. It's a cube. A net is what it's going to look like if I cut on my sides and I fold it flat. So I'm going to look at this and say, okay, here's the bottom of my cube. Then I have my sides of the cube. So I have 1 side, 2 sides, 3 sides, 4 sides, and then I have my top. So it's not going to be perfect, but it's going to be relatively looking like what it would look like. Where in our classroom could you find help on what a net looks like, Harper? Yeah, on my math word wall, the nets are right on one of my back cupboards. So sometimes we'll do different shapes. We're doing a cube today, but we will do different shapes. That net on the cupboards back there kind of helps us see what it would look like if we cut it and laid it flat. The second part with the net is label each side. So we need to look at the measurements of each side and where those sides are on the net. I'm telling you right now, this is the easiest one you're going to get. What makes it so easy? Robbie?
It's a square.
It's a square. They're all the same size. It will not be this easy next time. Okay? I know. Man, we have to learn this year. Oh, such a pain. So, you are going to label every side. If this side is 8 centimeters, going across from it's 8 centimeters, going across from it is 8 centimeters, going across from it's gonna be 8 centimeters, going across from it is 8 centimeters. If this side is 8 centimeters, folding up, the side next to it has to match it. It's a perfect square, right? It matches up. That Kleenex box, we don't want one side longer than another trying to fold it up. They're the same size. So we know these two are the same. We know these two are the same. The one across from it is going to be the same size. The one across from it is going to be the same size. So they're gonna fold to the same size. They're gonna fold to the same size. So like I said, this is an easy one because every single side, we just know without even thinking about it. We can label it 8 centimeters, but we do have to have that label on every single side. Next math packet, we really have to think through what side folds up to what side, make sure they're the same size. So next time, it'll be a little more challenging. Now, down here it says we need the surface area. To find the surface area, we need to find the area of every side. How do we find the area of a square? Abby? Length times width. Length times width. What is 8 times 8? Abby? 64. And it's going to be squared. Because it's centimeters times centimeters, so it's centimeters squared. So if one side is 64, because it's a cube, what easy thing can we do here, baby? Yeah, there are 6 sides. We know every single side is going to be the same measurement because they are squares. So I could just do 64 times those 6 sides. I'm going to put my answer on the surface area, and I'm going to write centimeters squared, because it was a centimeter times a centimeter. If they are different sizes, if it's a rectangle, and the sides are different lengths, like the Kleenex box in the back doesn't look like a cube like my Kleenex box up here, then you actually are going to go in and figure out what the different areas are for each shape in your net, and then you add them all together. Okay. Next page. We have an all classes page. So all of the classes are going to do those 3 parts. Write the formula for the volume of a cube. So for just that square, we knew it was length times width. When we add in the cube, we times it by the height also. So everybody is writing length times width times height on that first line. That is the formula for the volume of a cube. The second line says, show the calculation you will perform. What math are we going to do? We're going to fill in the numbers for those letters. We know this is the length, this is the width, this is the height. So we're going to put the math equation we're going to do. The length is 8, times the width, that's 8, times the height, that's 8. So I'm just writing the calculation that I'm going to put into my calculator. 8 times 8 times 8. The last one says, okay, what's the answer to that? What is the volume of this figure? So you're going to do the calculation. You're going to put into your calculator 8 times 8 times 8, and you're going to write the answer on the line. This time, does anybody know what our measurement's going to be? Robbie?
364?
Nope. I'm not asking for the answer. I'm saying look at the measurement. I put a centimeters. When we were finding the area of the square, it was centimeters squared. This time, we're multiplying 3 centimeters. So it's going to be centimeters cubed. Because we multiplied 3 different centimeters together. So you're gonna do the math to find those numbers. May or may not be the one that Robbie said. You're gonna do the math and check. Write that number there. Now we have to do the pre-algebra question to answer down here. What is the sum of the lengths of the figure's edges? So every single line here is an edge. So we want the sum of all those edges. What, I don't have numbers for all those edges. What would all those edges length be, Christina? How can it be 8 because it's a cube? Okay, easy working with these cubes. So you have to add them all up, or you could say, well, they're all the same number, so I'm going to count how many edges there are and multiply 8 by that number, and I will have this, all of the figure's edges added up. That answer goes down here. We are not multiplying anything, so the answer is just going to be in centimeters, because we're just adding all those edges up. Any questions on that page? All right. The Goldbach conjecture. This is having us work with prime numbers. All right, so I'm going to let you read through what all of that means, but I'm going to show you what you need to do to answer this. First thing you're going to want to do is know your prime numbers and know them all the way up. Our biggest number on here is 144, so you're going to want to do prime numbers really, really high. Do we need to go above 144? No. But should we know the prime numbers getting up to 144? Yeah. Do I expect you to have those memorized? No. I don't have them memorized. Where can we go to find that answer? Vivi? You can look it up. You can Google it. Not right now. But you can Google prime numbers to 144. And then what I do on my answer key when I'm trying to solve it is I write them out. Prime numbers start with 2. Okay. Prime numbers are those numbers that we can't divide down into other factors, just itself and 1. So 1 isn't a prime number because it's 1 and not itself. It's only the 1. So prime numbers start with 2. 3 can't be broken down. Can 4 be broken down? Yeah, so 4 is not a prime. 5 is a prime, not 6, because 2 and 3. 7 is a prime, not 8, because we got 2 and 4. Not 9, because it can be broken down to 3 times 3. Not 10. 11 is a prime number. So you're going to write those all out, all the prime numbers up to 144. Then we're going to look at our number, and it says, write each number below as the sum. Oops. So what does sum mean? Adding as few prime numbers as possible. So I'm looking at 10 and I go, oh, well, I could do 2 plus 3 plus 5. That equals 10. And I'm only using primes. But did I use as few primes as possible? No. Well, what else could I have used, Hadley? I could have said 7 plus 3, and I'm only using 2 primes now. So I'm going to try to see if there are 2 primes that I can add together to get it, or do I have to go with 3 primes? Not going to be any more than that. So all these answers, you're going to check to see, can I do it with 2 primes? Or do I have to go to 3? They have to be prime numbers, so you're really going to want to write out all those prime numbers. So you can see what the primes are, how close can I get to my number. Any questions on that? Okay, next page. Mean, median, and mode. You're going to do the pre-algebra one. What's the first thing we should do when we get to the mean, median, and mode? Luke?
Put the numbers in order.
Put our data set in order. I always say that's the first step we do because it's super easy to forget to do that. And when we go to the median, When we figure out that median, it might not be the number that you think it is because they're not in order. So put them in order. Then we're going to find the mean, the median, and the mode. There is no question for pre-algebra, so we don't give an answer. That doesn't apply to us this time. How do we find the mean? Hadley.
You add all the numbers, divide it by how many numbers there are.
You add up all the numbers, divide it by how many numbers there are. How do we find the median? Beckett?
Put them all in order and then put the middle one.
Median, the middle. They sound similar. Median, middle. So when they're all in order, find the number in the middle. If we have an even number, we're going to end up with 2 in the middle. What do we do when there are 2 numbers in the middle? Do I put both numbers? Or what do I do, Michael?
You find the middle one.
You find the mean of those 2 numbers. So your 2 middle numbers you add together and divide by 2. So I don't know off the top of my head if this is an even number or an odd number, but just a reminder, when you get those odd numbers, that's what you do. How do we find the mode? Robbie?
Whatever number is the most.
Mode most. We've got those O's in there. Mode most. Find the number that you see the most of. Next page, I think it's our last page. We always have a polynomial. Here's the thing with this page. You cannot flip, you cannot rotate. You can only slide these shapes over, and they all must fit in perfectly. So what I have some friends do is they might say, okay, so here's this shape. I'm going to go over here and maybe I'm going to put it right here. Okay, then I have, I'm going to put this shape right here. Oh my goodness, technology today. And maybe I'm going to put, snookies. I don't have anything left that I can put here going over, so I'm going to have to erase and try again. Okay? So it needs to be clear to me when I look at the final product, which shape is going where. I have some friends that once they figure it out, they'll go back and they'll say, okay, I'm going to do this shape is red, and I know it's spot on here. I know it's not here, but let's say it is. I'm going to color this spot in red. So that way it's really clear to me where your shapes are landing in your figure. We're not going to draw lines and say this goes here and this goes, because that is not easy for me to correct. So if you did that, you're going to go back and you're going to either draw the lines of where that shape is going to go, or you're going to color it in. Okay, you decide what's going to work for you. Does that make sense? No rotating, no flipping. It's just sliding that shape straight over. I can't turn anything to make it fit. Okay? With that, we are done with packet number 1. Remember, it is due on September 24th. That is a Tuesday. If you turn it in to me by the Friday before, which would be Friday, September 20th, I'll correct it, and if you have any mistakes, I'll give it back to you to fix up your mistakes. So every time you turn it in, I'll correct and give it back to you until September 20th. September 20th is that Friday. Is going to be the last day I'm going to accept papers to be given back to fix up. If you turn in on that Monday or Tuesday, the 23rd or 24th, then that's saying, yep, I'm done. You can grade it now. Okay? But if you turn it in to me early, I will show you which, I'll put stars on the ones you got, which pages are correct. And the pages that are not correct, you'll have the opportunity to fix up so you can get that 10 out of 10 points on this assignment. Any questions? All right, if you're listening at home, I hope you are well, and I hope to see you soon. Don't forget to like and subscribe. Have a wonderful day.